So this was the problem that we had ended our Google Meet on. All right, so let's revisit this problem. Because I know sometimes, depending on your bandwidth and my little whiteboard, could be difficult to see things, which is one reason I make these videos. Plus, you know, sometimes you may want to go back and just re-listen to the lecture, okay? All right, so we're looking at this. Let's first start with x plus 2y plus z equals 2. Okay, if we make both x and y equal to 0, we see that z is 2. If we make both x and z equal to 0, we get y is 1. If we make both y and z equal to 0, we get x is 2. Okay, so that's that plane. Now, you know planes are infinite. Okay, I'm drawing that triangle to show you a slice of that plane. So for the next one, we have the YZ plane. So the YZ plane, I don't have to graph it. It really is already graphed. Okay, but I will color in the part that would be the side of this tetrahedron. So let me get a different color pen. So here, okay, that is the YZ plane. That would be a face of this tetrahedron. So then we have the XY plane. Okay, however, we also have this x equals 2y. So the x equals 2y, let's start with that. Okay, so x equaling 2y. Oh, I thought I chose red. Okay. So when you have x equals 2y, if you picture this, this is x, this is y. X equals 2y is steep, right? It goes like this. So you're taking that and you're putting it on this graph. Okay, but you're drawing it at an angle, so you don't have to make it look quite as steep. All right, so I have x equals 2y. Okay, but now keep in mind, this here, this x equals 2y, you have to have a plane slicing through there perpendicular to that. All right, so this is going to then go up. All right, so, and keep in mind, this is your back face over here, right? Okay, then what do you have? You have the XY plane. So for the XY plane, it would be this bit down here. Okay, so I know it's a little difficult to picture, and you can always type this into 3D software and look at it, but what we're finding the volume of, okay, is this tetrahedron here in front of us. So let me just outline it. All right, this is your tetrahedron. Okay, and then you have, you know, your different faces. So it's the volume inside here. All right, so let's look at this. So the, okay, we need to sketch d, what we're integrating over. So we have x equals 2y, which is the same as y equals x over 2. And then we have x plus 2y equals 2. All right? So where I'm getting that from is that you have your x plus 2y, all right? The reason that that's going to equal 2 is because z is equal to 0. So here, if I make z equal to 0, I get this projection onto the xy plane. All right, so if I solve for y, this is y equals 1 minus a half x, or negative 1/2 x plus 1, whichever way you want to write it. So as I was saying, getting this region D is the most difficult part here. Okay, so x plus 2y is 2 is the same thing as this. Okay. So that's what you're integrating over. That's this piece here. Okay. All right. Now you have the back faces. That's why this is going from 0. Think about where these intersect. Okay, you should be able to get one in your heads. Okay, so this is going to intersect at 1. Those are in terms of x, and then we're going to start by showing respect to y. So this is type 1. So first we're going to respect y, then we're going to respect x. Now for the y, the upper curve is x over 2. The lower curve is 1 minus half x. Okay, then you have your x, you need your right, you need your left. Okay, and so the function, however, that we're going to be integrating, we need to solve for z, right? So if we solve for z, we get z equals 2 minus x minus 2y. So that's your integrand, 2 minus x minus 2y. All right, so first we're going to show respect to y. So 2 is a constant, x is a constant. So 2 minus x is a constant. And then when you integrate 2y with respect to y, you just get y squared. Okay, now I have to substitute in my functions. Okay, so these are going in for y. So I have 2 minus x times x over 2 minus x over 2 squared, which is x squared over 4, minus the quantity 2 minus x times 1 minus half x minus 1 minus half x squared. All right, so I'm going to pause and do a little algebra, and then I'll be right back. So you have to be very careful with the negatives here. So first I distributed x over 2 to 2 minus x. So that gave me x minus x squared over 2. Kept this, x squared over 4. Now this is going to be minus this entire quantity here. Okay, well this quantity, when I do my first, outer, inner, last. I don't care what anybody says. FOIL serves its purpose. All right, everything in math serves a purpose. Nothing is garbage. So you have 2 minus x plus x squared over 2. Then over here, when you multiply this, you have 1 times 1. You have negative a half x plus negative a half x, which is negative x. Negative a half x squared is 1/4 x squared. All right, let me pause and combine like terms. All right, so I got a common denominator here. I distributed my negative into here. I combined my x's. And then here you have, here you're going to have negative, negative. So that simply just becomes that. Okay, let me pause and continue to combine like terms. Okay, so I have all the x squared terms. I got my common denominator. Before I had a little mess up there with the 4. No big deal. You catch yourself making mistakes. You have to have confidence in math. You can't worry about making mistakes. You can often just recoup your mistakes. Okay, now this x squared over 4, because that's negative and then this is positive, those will cancel out. Always look for patterns. Then keep in mind, this is negative a half x squared, negative a half x squared. So that's going to combine, it's negative a half and negative a half to just negative x squared. All right, now if you look at the linear terms, we have x, 2x, so that's 3x. We don't even need to think about that because these could have just canceled, right? So we get plus 2x. Okay, and then we look for the constant terms. So the constant terms are negative 2 and 1. Okay, so that entire mess cleans up to this. All right, so let's continue from there. So now we have this, and then from there, it should be light work for you guys. Keep in mind, check out the 0. This will end up having an x, so the lower bound won't matter here. But always check. Never just assume. Take a moment. It only takes a moment to check. Okay, so integrate this, and then you're only going to have to put in the 1. So we get negative 1/3 plus 1 minus 1. All right, nice. Okay, so the entire volume comes out to be negative 1/3. Let me pause and just check my sign. Hold on one sec. Okay, so I went back and I looked at my work because the negative 1/3 made me pause because that didn't make sense to have a volume of negative 1/3 in this case. So I realized that way back when, okay, and this is one of the great things about math, is that you will find yourself, you know, making mistakes. I switched these bounds by accident. So if I switch these bounds, we have a property of integrals that tells us that if you switch these bounds, that meant the sign changed. So that would be a positive 1/3. Okay? All right, guys. Hope these videos helped you. Thank you.